Alright, assalamualaikum and greetings everyone. Welcome to another lessons video. So today I would like to teach you all about the force oscillator. So before we go further into the force oscillator, I would like to do some refresh about the damp oscillator, because the damp oscillator will have a relation between to the force oscillator. Alright, let's begin our lesson today. Right. So first I'm going to talk about damp oscillator. Damp oscillator. And in right here is about the force oscillator. Force oscillator. Or we call it as the driver oscillator. It's the same name, okay? So in this case, okay, I'm going to talk about damp oscillator. So let's say that I have a system which is a block on horizontal spring, okay, like this. And then here is the block. Alright, here you see, okay. It's like here. Okay, right here, this is where the equilibrium position is. Right here. Equilibrium position, which is x equal to 0. Alright, and then here let's say that the object is moving to the right. It is right here, v, or we can call it as the x dot right here. Okay, now the object, when this object is moving to the right, okay, there is two forces that acted on this object, which is, the first one is what we call it as the damping force, or we call it as a resistance force that oppose the direction of this moving object. And then the second one is the restoring force, which is the force that is inside the spring, Fs, okay, equal to negative Kx, while F del is equal to negative gamma x single dot. Right? Okay, and then let's write the force distribution in this system. So force distribution. So when it comes to a force distribution, always relate to the second Newton's law. Okay. Now, here I will write a little different from the previous lecture, because in the previous lecture I write it like ma mx double dot equal to negative f dam minus fs, right? So no, I will not write to be right like that, because I would like to change the wrong here, the wrong concept that I've done in the previous lecture. So firstly, we have to write the F net, which is what we call it as the net force. Alright, the net force is defined as the sum of total forces acted on the system, and also it is equal to ma, second Newton's law. Alright, very simple. Now F net, when we apply the definition of this the definition of the net force, so F net is equal to F dam, right, plus with the Fs, right, and then F net is equal to Ma, which is equal to F dam, which is negative gamma x single dot, and then minus with the Kx. And A will change into the simple harmonic motion form, which is mx double dot equal to negative gamma x single dot minus negative gamma kx. Okay, simple. Alright. Now let's put all of this to the left side, so we get that mx double dot plus kx plus gamma x single dot equal to 0. Sorry, I have to do some motions. Okay, mx double dot plus gamma x single dot plus kx equal to 0. Alright, it's simple. Now every component will divide it by m, because we want to remove the mass in the system. So finally we get that x double dot plus gamma over m x single dot plus with the k over m x equal to 0. And we know that k over m is equal to omega naught squared. right? Because omega naught equal to square root of k over m, and omega naught equal to omega naught square is equal to k over m, right? So finally we get that x double dot plus gamma over m x single dot plus omega naught square x equal to 0. So this one right here is how we get the differential equation of motion for the damped oscillator. Alright, differential equation of motion of damped oscillator. Alright, it's simple, right? Okay, so far so good. So far it's pretty easy. Now let's move on to the general solution. So for the general solution for this one, okay, we have a general solution, alright, which is xt equal to exponential power of alpha t times x capital X. So this is the general solution. Right. That is all about the damped oscillator. Now let's move on to the force oscillator, or we call it as a driven oscillator. Alright. So same here again, we have the same system which is blocked on a horizontal spring. Alright. Okay, and then block here. Alright. And then again, let's say that this one is the equilibrium position, which is EQ x equal to 0. And again, this block is this system is moving to the right, x single dot here, and here we have a 3 force exerted on the system. Okay, on damped oscillator there are 2 forces, but here we have 3. Right. So the first 2 force exerted on the system is basically same as the damped oscillator, which is the first one is the F damp, and the second one is the restoring force, Fs. Alright, there's another force that follows the Z movement of the system, which is right now the system is moving to the right, So that means we have a force that is opposite the direction of these 2 forces right here, which is F T. So this force right here is what we call it as the driving force. Alright. Why does this force exist? Is because we want to overcome the loss of energy made by this damping force here. This damping force makes the object to stop moving, right? Because of this, the presence of this force makes the object to stop moving. So to overcome that, we will put another force, external force, okay, to overcome this problem, so that the system will oscillate smoothly without any change of velocity or maybe loss of energy. Right. Very simple. Right. So the force distribution in this system, So the force distribution, again I'll write it again, F net, okay, equal to F damp plus Fs plus Ft. And Ft, okay, F net is equal to mx double dot equal to negative gamma x single dot negative kx plus with the F naught cos omega et. So F naught is known as the amplitude of driving force. And this right here, the omega E, is known as the angular frequency of driving force. Alright. Now let's continue the calculation. So right here I would like to resemble, okay, this equation. I would like to do the exact same as this one by bringing all this component only to the left. Alright, so finally we get that mx double dot plus gamma x single dot plus kx equal to f naught cos omega et. Alright, and every component will divide by that by m. Alright. Oh shoot, I'm so sorry. Alright. So what happens if you get that x double dot? Alright, plus gamma over m x single dot plus with the omega naught square x equal to f naught over m cos omega et. So this is what we call it as the differential equation of motion for the damped oscillator. This is a differential equation of motion for forced oscillator. Basically, this is how we pronounce it. Right? We call it a forced oscillator in this lecture. Okay. Now the general solution. Right? The general solution is a bit different. So general solution, it is say that xe is equal to xht plus xpt. Right? So this is the solution is that the solution is that equal to the sum of general solution of the damped oscillator, which is here, plus with the particular solution, right? So this one right here is actually general solution of damped oscillator. Alright, and again this system will become xt. Okay, this you have to copy this one, but this one right here you don't have to follow, but I have to show you, right? So xt is equal to exponential power of alpha t times with the x capital xt plus with the xpt. So this general solution shows a two state. Okay, so this state is what we call it as the transient state. And this one right here we call it as the steady state. This one right here is very important because we want to find what type of forced oscillator is this. Okay, and this one right here we already we know how to find it. Like for example, like gamma is equal to 2m omega naught is a case for the critically damped, or maybe gamma less than 2m omega naught is a case for the under damped, and then gamma is more than 2m omega naught is a case for the over damped. So we know how to find this, right? But the problem is, how do we find this steady state? So to find steady state, okay, we have to go further. Okay, now let's move on to the second page right here. Right, boom. Alright, okay. Now the problem is now that how do we find the XPT, right? But don't worry about it. So they do some hypothesis that XPT, right, equal to A cos omega et minus delta. So A, we know that A is the amplitude of the system. Omega E is the angular frequency of the driving oscillator, and delta is known as the phase lag. Alright. Now let's move on. Alright. So since we have the general solution for this the general equation for the displacement or the particular solution, alright. So right here we can actually find the velocity here by differentiating this equation. So at single dot vet, we get that it is equal to omega e, and then times with the cos will become negative sign, and then copy back omega et minus delta. Alright. So finally that at single dot vet equal to negative omega ea sine omega et minus delta. Alright, this is the velocity of the particular solution. Alright. Now for the velocity, so s double dot pt is equal to omega e, okay, omega e times with the negative omega ea sine will become cos omega e t minus delta. So s double dot pt equal to negative omega e square A cos omega et minus delta. Simple here. Good. Alright, nice, pretty good. Now, since we have the three components here, 1, 2, 3 here. Now let's get back to the general. Let's get back to the differential equation of motion. So we know that general equation of motion, right, which is x double dot, or plus with the gamma over m x single dot, plus with the omega naught square x equal to f naught over m cos omega et, right? So we will substitute x double dot, x single dot, and x without dot from this one. Alright, so what happened that we will get that for x double dot is negative omega e square a, and then cos omega et minus delta. Alright, pretty simple. And then plus with the gamma over m, and then I multiply with the x single dot, which is negative omega e a, and then times with the sine omega et minus delta. Okay, and then plus with the omega naught square. Okay, you know what this right here. Okay, plus omega naught square times with the a cos omega et minus delta, which is equal to f naught over m cos omega et. Right. So right here I would like to do the factorization, so to short down the equation. So this one you can pull out here, you can pull out here. Since that we have the same cosine function here, so we get that omega naught square plus omega naught square minus with the omega e square, and then times with the a times with the cos omega et minus delta. Alright, and then plus with the gamma over m times it should be negative, because gamma over m times with negative omega ea is equal to negative gamma over m omega ea, and then times with the sine omega et minus delta, okay, which is equal to f naught over m cos omega et. So right now we're done. Okay, we're done now. This one right here. Alright. But now the problem is, I would like to form the cosine function just like this. How do we do that? Okay, right now we are different, I know. On the left side it is different. Okay, omega et plus minus delta, but this one is omega et. There's no minus with delta, right? So we have to form another form for this one to become just exactly like the left hand side here. So let's do that by doing a substitution. So f naught over m cos omega et equal to f naught over m multiply with cos omega et minus delta. Okay, this is what we want to form, but at the same time we have to counter this system. What we do is, this is like what we call that? What we call it as a conjugate. So that minus delta plus delta equal to omega et only, right? But here we want to find this form here. So finally we get that this one right here. Okay, I'll put this on here. So this one right here, we have the omega et that minus delta plus delta. This one right here can break into a trigonometry identity, which is cos a plus b. Okay, where a is equal to omega et minus delta and b is delta, right? Because omega et minus delta is a, and then plus with b, which is delta here, right? So cos a plus b equal to equal to cos A, cos B, okay, and then minus with sine A, sine B. Alright, very simple. Alright, so let's go here. Alright, hold on, let me see my camera here. Okay, so f naught over m cos omega et equal to f naught over m, okay, and then cos is cos b, which is cos a, which is cos omega et, cos omega et, and then cos delta. Alright, it's simple. And then minus with f naught over m, and then times with the sine omega et sine delta. Alright, so this is how we got it. Okay, pretty easy. Now let's get back to this form right here. Do a substitution here. So when we get that, alright, we get that hold on. So we get that omega naught square minus omega e square, alright, and then times with the cos omega et minus delta, alright, and then minus with gamma over m omega ea times with the sine omega et minus delta, and then equal to f naught over m times with the cos omega et minus delta cos delta, alright, and then plus with the f naught over m open bracket sine omega et minus delta sine delta. This is simple. It should not be plus, it should be negative. Negative, right? So this one right here we can do what we call it as comparison, right? So this one right here, see we have the same type of cosine function here. So this one will equal to this one, so A equal to B, and here we have the C right here. We have the same type of cosine function right here. So this one will equal to D. Alright, so what happens if we get that? A equal to B, right? So omega naught square minus omega e square. So A, okay. Wait, why did I do that? Hold on. No. It should not be square here. Oh my god, why did I do that? I am so sorry. So omega naught square minus omega e square times with the A, the amplitude, and then we open up. So cos omega et minus delta, this will equal to B, which is f naught over m here. Hold on, what did we get? Okay, hold on, okay. F naught over m, and then cos omega et minus delta cos delta. Alright. So this one can be cancelled with each other, cos this cosine function. So finally we get that omega naught square minus omega e square times with the A equal to f naught over m sine delta. Is it? Oh, I'm so sorry. It's cos delta. My bad. Cos delta. Alright, simple. Now let's get to the B equal to C. Sorry, C equal to D. I'm so sorry about that. C equal to D. Alright. Sorry about the camera here. It's so tough. Okay. C equal to D, which is equal to negative gamma over m omega ea, and then sine omega et minus delta, which is equal to negative f naught over m, and then open bracket sine omega et minus delta sine delta. Simple. So here again I'll cancel out the same type of sine function here, and then at the same time we remove this negative here, and finally we get that gamma over m omega EA equal to sine delta. Sorry, oh my god. Okay, F naught over m sine delta. Right? So this is what we get. This one right here. This one right here. Now let's move on. So this one right here, okay, we will substitute it into the equation motion right here, differential equation of motion right here. Okay, right now, okay, I'll do it. Oh, okay, well, never mind. We have another equation. Okay, let's continue back. So alright, so we know that F naught over m cos delta is equal to omega naught square minus omega e square A. Okay, simple here. So F naught over m sine delta is equal to is equal to gamma over m omega e A. Alright, simple. Alright. Hold it as the oh my god, the camera. I'm so sorry. So this one right here, what happened? We will do what we call it as this square box side here. Why we would like to do the square box side here? Because we want to remove this right here. We want to remove the form of this function right here. So to remove this, we will do what we call as the square box side, because we want to get this form right here: sine square theta plus cos square theta equal to 1. This is what we do to remove the sine and cos function. Right? Right, now let's do it. Oh shit. Alright. So here, so omega naught square minus omega e square, and then times with the a. Alright, and then times with itself, which is omega naught square minus omega e square times with the a. Alright, and then this one becomes to the so here become negative. Is it negative? Yeah, negative 2. This is gonna be okay, omega naught square minus omega e square, and then times with the a, and then gamma over m omega e, so it should be a square here, right? Okay. Alright, and then plus with the gamma over m omega e a, that's with itself, right? So gamma over m omega e a, right, it is equal to f naught square over m square cos square delta. Alright, and then minus with the 2f naught over m cos delta sine delta. Alright, and then plus with the f naught square over m square sine square delta. So this one right here will be removed. Alright, this one will be removed because 2 and then omega square minus omega here e square a square here, which is the cosine delta here, and then a square omega over m and gamma over m omega e, and then a square is actually the sine delta. So that's why we cancel out this one. So what left we get here is this form right here. Alright, so let's write back. So omega naught square minus omega e square, alright, and then square a square, alright, because this both will multiply with each other, so we get the square here, and then plus with the gamma over m omega e a, and both of these will become what we call it as the square equation here, because we multiply with each other right here inside here, and then we get that f naught square over m square cos square omega e t. Alright, sorry, not that, cos square delta, and then plus with the f naught square over m square sine square delta. And here we can do what call it as the what's that called, factorization, sorry. So omega naught square minus omega e square, alright, times with the a square plus with the gamma square over m square omega e square a square equal to f naught square over m square cos square delta plus sine square delta. So this one right here, like I said, we finally get the form right here, sine square theta plus cos square theta equal to 1. So this one right here will equal to 1. So that means f naught square over m square multiply with 1. That's what it means. Alright. So finally we get that the equation is omega naught square minus omega e square, okay, times with the a square plus gamma square. Wait, is there a right here? Is it? Wait, hold on. Oh yeah, it is. Okay, gamma square over m square omega e square a square, alright, equal to f naught square over m square. This one we should do right again. Okay, we have changed it to equal 1. Alright. Now we do factorization again. So this one have the a, this one has the a. So we will get that a square multiply with omega naught square minus omega e square. Okay, so it should be a here square, and then plus with the gamma square over m square omega e square equal to f naught square over m square. So this one right here, we can actually find the amplitude of the system, right? This one right here. So to find that, let a as the subject. So a square equal to f naught square over m square, right? Over omega naught square minus omega e square plus gamma square over m square omega e square, right? It's simple. Now this one right here, we will square root both sides to remove the square, right? So here. So this one right here, we can predict that what happened when we square root both sides, which is equal to f naught over m. Alright. So finally we get that a is equal to f naught over m over square all of this. It is omega naught square minus omega e square plus gamma square over m square omega e square. Alright, pretty simple. Now this one right here is really important. When the question asks you to find the amplitude of the system in steady state. Why it's called that in steady state? Because this form right here, okay, it comes from the XPT, right? So XPT is for the steady state solution. That's why it's called steady state, in steady state. Alright? Very simple. Now let's get further into our lesson here. Let me see. Hold on. Let me see my notes here. Hold on. Let me see. Is this one? Is it this one? Oh, yeah. Okay, yeah. Okay, now we know that okay, hold on. Now, if we do dividing with each other, okay, let's say that f naught over m, and then f naught over m sine delta, okay, over with the f naught over m cos delta equal to gamma over m times the omega EA over with the omega naught square minus omega E square A. So we would like to find how much the phase lag here. How do we calculate the phase lag, the delta here? How do we calculate this one? So this is what we try to do here. So what happens is that this one can cancel out each other, this one can cancel out. So sine over cos, we know that sine over cos, sine theta over cos theta is equal to tan theta. So tan theta is equal to gamma over m omega E over omega E square minus omega naught square minus omega E square. So this is how we find the delta, right? This is what we call as a phase difference. And finally we get that theta is equal to tan inverse tan gamma over m omega E over omega naught square minus with omega E square. So this is how we obtain the delta here. This should be the tan delta here. This should be delta here. Alright, very simple. So both of these are important. Please take note. Right. So now let's look back to the displacement equation here. Right. We know that the particular solution, which is xpt, is equal to a cos omega E t. Right. So the minus delta should be minus delta. Oh, let me get minus. Yeah, okay. Minus delta. Right, so A, we know what is A, and we know what is delta. So notice that, okay, A is equal to this. It does not depend on time, right? Same as delta. Delta also doesn't depend on the time. So that means that, oh my god, what happened to my camera? Okay, again. Okay, xpt is equal to a cos omega E t minus delta. So notice that this variable right here, okay, let's say that the amplitude. So the amplitude does not depend on the time. Okay, it does, which means that this amplitude will not change over time. Same as delta. Delta also, we don't see that there's time in here. So that means that these two form right here, okay, we call it as the two independent constant, which shows that it doesn't show initial condition. What I mean is that back in the damn oscillator, to find the maximum velocity, okay, to find the maximum velocity, we will say that t is equal to 0, and then we do some substitution, right, like that. But in this one we cannot do that. That's the problem. So that means that the force oscillation, okay, will when it oscillates, we will forget its initial conditions. Okay, that's what happened. So that's why we have two independent constants that will not show any initial condition of the force oscillator. So that's actually a quite problem here. Okay, but it's okay. Okay, about the graph, okay, I will not talk about it now, but I will talk about it later. Okay, now let's move on to our next lesson. See here, let me see. Yeah, let's move on to the power. Okay, now we're done here. Okay, we're done. We're not gonna look at it again. Okay, now let's look at the force. Sorry, the power on the force oscillator. Because force has the power is have a relation between the energy. So this is the power in force oscillator. Right. Hold on, let me get let me correct my. So we know that power. The definition of power is actually the rate of change of energy of the system. Alright. So here we have a form, rate of change of energy of the system. Or we can write it as the power is equal to rate of change of work done. Okay. So that means that energy is equal to the work done. Right. So when we write the differential equation for the power, so we know that power, which is represented as the P, So P is equal to differentiation of work done, which is omega W. Rate of change of work done, so dW over dt. Alright. So we know that W is equal to F times V the S, which is force multiplied with displacement. So W is equal to F times V the X. For this one, for the work done, always remember that F is a constant. It cannot be changed. So let's write back. So P is equal to D, and then times the work, which is F times with the X over dt. And we know that force is a constant, right? So let's put aside here. So P is equal to F times with the dx over dt. So dx over dt, which is the rate of change of displacement, which is the definition for the velocity. So this is what happens. So P is equal to F times with the V, right, velocity. Finally, P is equal to F times the X in the power. So this is how we obtain the formula for the power. Right. Now let's look on how do we calculate the power for the damping force. Damping force. So damping force here, hold on. Oh man, I need to actually buy a mic here. It's actually really tough to use. So for damping force, let's look on the damping force. So for damping force, to calculate the power for the damping force, so we know that damping force, which is F damp, is equal to negative gamma X single dot, right? So to calculate that, to calculate the power of damp, so it should be F, which is F damp times with the velocity, right? So finally we get F damp and P damp, which is power damp, is equal to negative gamma X single dot times with the X single dot. So finally power of damping force is equal to negative gamma X single dot square. Right, pretty simple. Now, since that the system is we are now focusing on the steady state form. So that means X single dot, this right here, is equal to X single dot P square, and X single dot P square, we know that it is equal to negative omega E A sine omega E T. And then we have to square both sides here. not square, only square this side here. So we get that x dot p square is equal to omega e square a square sine square omega e t. Okay, very simple. Now let's write back. So the power of damping force is equal to negative gamma omega e square a square, and then times with the sine square omega e. This one right here. Oh, we calculate the power of damping force. Right. Now when the system is oscillating, okay, we want to find the average of the power exerted on the system. What is the average power for the system here? So to find that, okay, we know like here we have the sine square omega et, right? So the average of value for the sine square theta, okay, this is a fact which is equal to 1/2. So that means sine square omega et equal to 1/2. So what we get at, we use this form right here, which is right this form right here. How do I say that? I don't know. It's like a bracket, but not actually a bracket. Okay, we use this to calculate the average power. Alright, so P then, like this form here, is actually the average power. Alright, so why do we find the average power? It's because we want to satisfy for the total energy. So total energy, okay, of the system is equal to the average power of the dam, okay, sorry, dE/dt is equal to average power of them plus with the average power of the driving oscillator, the driving force, which is Ft. Okay, but later we'll find that. Okay, this is why we want to find the average power. Right, so P then is equal to since this one is equal to 1/2, right? So finally we get that negative gamma omega e square a square times with the 1/2. So finally that the average power for the damping force is equal to negative 1/2 gamma omega e square a square. Boom. Done. Now let's look on the another force power, okay, which is the power for the external force. So again, we know that we apply external force on the system, which is Ft, right? So Ft is equal to sorry, can you see that? Oh, never mind. Ft is equal to F0 over m cos omega et. Alright, so to find driving force, so F, we call it P ext present as the power of the external force, because this is known as the external force. Okay, P ext is equal to Ft times with the x single dot. Alright, it's simple. Yeah, it's simple so far. Alright, okay. So this one here is equal to P external force is equal to F0 over m cos omega et times with the x, which is xpt. This one, right, for the displacement, okay, in the steady state form. Okay, so xpt, x single dot pt is equal to negative omega ea and then sine omega et. Yeah, that's it. Okay. Let me see. Did I write it correctly or not? Hold on. I think I made a mistake over here. Let me see. Yeah, I did. Oh my dear. Alright. let's get back to this form right here again. Wait, did I do it right? Yeah, oh, so this one right here. Oh no, okay. This should be omega et minus delta. Okay, my bad. Right here. Right, and here should be omega et minus delta also here. Minus delta square, and then one is right here, it should be negative delta here. Omega et minus delta here. Okay. Oh no, I'm so sorry. How long did I record it? It's been 1 hour. What the hell? Okay. So here, again, sine squared theta. Yeah, sine squared theta is equal to omega et minus delta here. Omega et minus delta equal to 1 over 2 sine squared. Alright. Now let's get back here. What the hell? What? Okay. Oh, sorry. I was fine. Okay. Right here. So, should we change here? To a negative delta. Okay. Oh man, it's beautiful. So power of external force is equal to can you see that? Okay, yeah. Is equal to F naught over m cos omega et times with the negative omega ea sine omega et minus delta here. Okay, yeah. Okay. Minus with omega ea sine omega et minus delta. Right? Yeah. And we know that the F naught over m cos omega et, right, is equal to such a long equation. If you remember again, okay. It should be wait, never mind. No. I'm so sorry. Don't look at this. Look at here. So this one is has a form for the sine trigonometric function. Trigonometric identity, which is sine A plus, not plus, it should be negative here, sine A minus B. So sine A minus B is equal to sine A cos B minus with the cos A cos B. Right? So P external is equal to F naught over m cos omega et. Okay, multiply with the negative omega ea, and then sine A which is sine omega et, and then cos delta, and then minus the omega. It should be positive right here, right? Yeah, positive omega ea cos omega et sine delta, right? Yeah. Okay. And then what should I do here? Let me see. Yeah. Okay. So we can multiply straightforward. So P external is equal to F naught over m times with the negative omega ea, and multiply with the cos omega et sine omega et cos delta, right? And then plus with the F naught over m omega ea, and then times with the cos omega et cos square omega et, right? And then plus with this, sorry, not plus, sine delta. Straightforward, sine delta. Alright. And that is how we find the power external. This is the final. But here again it's too complicated, right? So we want to find the average power of the external force. So average power for the external force. Okay. Alright. This right here we have a fact that, okay, cos omega et and sin omega et, the average is equal to 0. And here right here, the average is the same as the sine square theta, which is equal to 1 over 2. So let's do find the power external here. So negative omega EA F naught over M, right? And here we come to multiply with 0. 0 times cos delta is equal to 0, so times 0 times with the 0 equal to 0 here. Okay, and then plus with the F naught over M omega EA times with the 1 over 2 sine delta. Right? So finally we get that the external power is equal to F average, 1 over 2 omega EA F naught, alright, and then times with the sine delta. There you go. Pretty simple. Wait, is there any F naught over M in this one? I don't think so, right? Yeah, again I made a mistake. This one should be. It should be F naught cos omega et, not F naught over M. I'm so sorry. I'm so sorry for the chaos mistake here. I'm so sorry. Yeah, this is the final form. Alright. To find the power, external power. Alright. Alright, that is all. In the next lesson I will talk about the graph of the system. Alright. Thank you very much and stay tuned.